Alright, what's up guys? This is our video for Affine Cipher decryption. Um, so it basically uses a lot of the same properties as the encryption method, but it's just slightly different, specifically the equation that we used. So as we know, whenever we're encrypting affine ciphers, we use the equation y equals ax plus b. But for decryption, we actually use the equation x equals a prime times y minus b. All right. And if we're dissecting the equation, basically x is, I guess you would say it's our plain text. Basically, whenever we're decrypting, we're trying to find out what the plain text actually is, what the message actually says. So that's what our x is. And an a prime, that's going to be different from what we referred to as a in our encryption video. It's a completely different number, and I'll explain how to get that number. And then B is going to be the same, and then Y is just your encryption letter, I guess you would call it. And I'll explain more about that as we progress. So if we're taking a look at an example, this example says, decode this quote referring to a 2020 presidential candidate, which has been encoded with an affine cipher of a equals 23 and b equals 6. So upon reading this question, we're just going to focus on what a and b are. So a is 23, b is 26. So I'll just write those numbers for now, just for reference. Okay. So what we do now is we have to find out what a prime is. So that's when we're going to go to our chart. And I realized I did this wrong earlier. So this is actually going to be a correction of what I taught earlier. So we don't actually look at this chart, but we actually look at the one below it. And unfortunately, my camera quality is not that great, so you can't really see the numbers. But what we're going to do is, since we know that a equals 23, we're going to look for where 23 is on the chart. And we know that 23 is right here. And then we're basically going to look at whatever's on the opposite side of that number, which is this number over here, which is 17. So that's going to be your a prime number. But just to clarify, let's say we have a number that's not on the top row, but it's on the bottom row. So let's say a was equal to 19 over here. So then we would know that on the other side of that spot, which is 11, that's going to be our a prime. So make sure you're not confused about this whole process. It's not that you have to start from the top and whatever's on the bottom is your a prime. It's basically whatever's on the other side of a. So in this case, let's look at 19 here. Let's say that was our a, so on the other side it's just a prime. So that's 11. So that's pretty much how you find a prime. So in this case, we know that a prime is 17. So let's go ahead and fill out the equation, or just plug in the numbers. And again, b is just going to be the same. It's always going to be 6. So if we're writing numbers, 17 times y minus 6. All right, so that's going to be our decryption equation. And then what we're going to do now is we're going to go back to our example. And we're going to look at the first letter that's given to us. So again, unfortunately, you can't really see it that well, but this is an E. So we're going to look on our chart to find where E is, and that's going to be 4. So we're just going to, for now, write 4 on here just for reference. And then, like I said before, you can go ahead and fill out the rest of these letters, try to find the numbers that they correspond to, and then just write them on top. It's going to be really helpful later on. But let's just focus on E for now. So we know that E is 4. So we're going to plug that into Y. So that's going to give us X equals 17 times 4 minus 6. And that's just going to give us, if I'm doing mental math, negative 34. And now we have to mod 26 this. Like I said, with negative numbers, because this number is fairly small, all we have to do is just keep adding 26. In this case, we're just going to add it twice. So negative 34 plus 26 plus 26. That's going to give us 18. So we know that that's 18. And then if we look on our chart, we know that 18 is S. So on our example, for E, we're going to write S. And I'm just going to try to figure out the remaining two letters of this word. So if we take a look on our chart, we know that L is 11. So I'll just write that here for now. And then we're just doing the same process. Plug in 11 for Y in this case. And then we're just going to solve that. So that's basically 17 times 5. And then we're just going to mod 26 that. Subtract 3 times 26. So that gives us 7. So if we take a look on our chart, try to find 7, that's going to be H. So for L, I'm going to write H. And you can probably guess that this is the word she. And whenever you're doing this in actual competition, I recommend just, guessing she. Don't waste your time doing another equation. It's really just worth it to just guess. But in this case, I'll just finish it off. I'll do one more example. So U, if we take a look on our chart, we're going to try to find U, and that's 21. That is 21, right? No, sorry, that's V. We're looking at U, so that's 20. So I'll just go ahead and write 20 here, and then we're just going to plug it into that equation. And then if it is E, then we know that what we're doing is correct. So yeah, let's go ahead and do that in our calculators. It's going to be 14. Oops, I wrote that wrong. 14 times 14. All right, 238 divided by 26. Subtract 9 times 26. 4. So 4, as we know, it is E. I'll double check. Yep. So E is 4. So we're just going to go back to our example, and we're going to write E here. And then again, make sure, every time you see E, L, U, you just replace it with those letters. So that's pretty much it for decrypting Affine ciphers. Once again, if you have questions, feel free to contact me. And then, yeah, hopefully you guys get more comfortable with this. Yeah.